Welcome back to the channel. Today it is our first main concept of our DSA course based on priority queues and all the main concepts you need to know for solving questions based on priority queue. First, a very small introduction. A priority queue is a structure similar to a queue, just that each element is sorted. Means the entire queue is sorted. However you insert the elements, once you pop the elements, they will be popped in a sorted order. Okay. Now let's move forward to the questions. If you want to hear an entire detailed introduction and working about the queue, make sure to watch our introduction to data structures video. I will pin in the description. Let's start off with a very basic question. You have a kids ticket counter and you need to handle n events. There are two types of queries, type 1 and type 2. For type 1 query, a child of age X enters the queue. For type 2 query, you lend a ticket to the child of smallest age. And after every query, you need to print who is the smallest child in the queue. Okay, so all you have to do is, if type is 1, take the input and add it to the queue. If the type is 2, pull out the first element from the queue, and at every operation just print the top element of the queue. That's all you need to do. Okay, now we will learn how to write custom comparators while using our priority queue. I'll show you in both languages, C++ and Java. Now, custom comparators are very important because in many questions you might need to compare values on based of two or three values. So that time we can make a priority queue of vector, and we will define a custom comparator that a vector needs to be sorted within the priority queue on basis of what. Okay, so this is how we do it in C++. First we define a priority queue of vector, then we need to define what does the final list look like. Since this is a list of list, we will write vector of vector. And now we need to specify our comparator over here. Let's just name it compare for now. Okay, now we need to define this comparator. Okay, so let's create a struct compare. Okay, in, in inside this we need to create an operator which will define how will the vectors be sorted inside the priority queue. Bool operator, then 2 times brackets, and you need to insert parameters vector A and vector B. Now this vector A and vector B are two different vectors pushed in your queue, and you need to define which vector should be ranked first. Okay, now if we want to sort these vectors based on smaller first value, then we need to write return A of 0 more than B of 0. Greater sign means ascending order. Less than sign means descending order. Okay, this is kind of like, I'll show you some output. If we push 3 comma 4 first and then we push 2 comma 5 later, we are sorting with respect to the first value. So while I print my values, it looks somewhat like this. So you can see 2 comma 5 gets printed first and then 3 comma 4 because we have sorted with respect to smaller first value. Now if there are multiple conditions, like if the first value is equal, then we must sort by smaller second value. Then we do it like this. If a of 0 is not equal to b of 0, then we return by this, else we return by first value. To see if this works, we'll add another 2 comma 7. So 2 comma 5 must be printed first and then 2 comma 7. Okay. Now if you want smaller first value and greater second value, then you will just reverse the sign of this and see 2 comma 7 comes earlier. So this is how you can create your custom comparator for priority queue in C++. Now I'll show you how to do the same in Java. Okay, in Java, first you define a priority queue of long array. Okay, queue is equal to new priority queue. Now we need to define our comparator over here. A and B refer to two long arrays pushed in the queue. Okay, something like this. Okay, now if A of 0 is more than B of 0, this was for ascending, then we say return 1. Return 1 means we need to sort. If if a value A is greater than a value B, which means we need to sort because we want smaller first value. Okay, so this sentence means I want to sort if the first value is smaller, and this always requires a return -1 at the end. Return -1 means we don't need to sort, means for all conditions except for this case it will not sort it. Okay, now let's push some values in the queue. 2 comma 5, let's put 1 comma 6 here, and let's print it. Okay, so if you can see, the first value which is smaller gets printed first in the queue. Okay, now if we want to do the same, like here we wanted, if the first value is same, we do based on second value, then we make it if A of 0 is equal to B of 0 and A of 1 is more than B of 1, return 1. You can similarly place how many ever conditions you want to sort this queue. Now if I add another inside this 1 comma 3, then 1 comma 3 should come first. Okay, and same way if I reverse this polarity, then the greater second value comes first. So in this way we can put how many ever conditions we want in this comparator and in the C++ comparator. This helps us to tackle advanced problems with priority queue when we need to compare values based on 2 or 3 parameters, not just one like in the regular priority queue. Now as an example, let's solve this question. In this question, whenever a type 1 query occurs, you need to insert a politician with X money bribed and Y work done. and whenever a type 2 query enters, you need to expel the politician having highest money bribed and highest work done. That means inside your priority queue, you need to sort the items based on greater first value and then greater second value. Okay, let's copy our this comparator over there so you can directly use it. Okay, now we wanted greater first value. This was for ascending. Since we need descending, we will flip this polarity. Okay, now since there are key cases, I will add it over here. Okay, now first of all, let's take input. I'll define my priority queue and compare. Okay, now what does my query says? First I take a type. If my type is 1, then I need to insert money bribe and work done. I'll change this to long since we might be handling big values. Okay, now we will insert in the queue this politician. Okay, now whenever a type 2 comes, we need to expel the politician having highest money bribe and highest work done. This is expected to be at the top of your queue. So if your queue has at least one value, we pop it. Okay, and then after every moment we need to print the politician at the front of the queue. So if queue.size is equal to 0, then we print -1, else we need to print the one at the top of the queue, right? So we print the stats of the politician. Okay, let's just execute this. Vector, acha, so don't need to pop over here, we just need to print it. Got it. Yes, now the output is correct. Nice. Okay, so this was a basic question where we sorted elements inside a priority queue when one item depends on more than one items for its priority. This technique can be used in many other questions. Okay. Now, this is an example of a question where we need to sort elements of a list based on some condition. Now, if you have to sort all the elements, then you can directly put a comparator on a regular list or vector and sort them. But if you want to sort elements at different indexes which are not continuous, then we cannot use the previous method. We need to use a different technique which is a priority queue way. Okay, you have n elements. Each of the elements are part of either first, second or third sublist, and you want that if you pick elements of any one list, they should be sorted. Okay, if you take this example, 8 and 1 the 0th and 4th index, both are the 0th and 2nd index, 8 and 5, both are part of first sublist. So when you pick up all the elements of those lists, it should be sorted, which means I want 5 to come first, 8 to come next. Same for the third sublist. 1 should come first and 4 should come next. So how do we do this? Okay, this is an example in which, wait, I'll show this one. Okay, over here I have used three priority queues. Okay, this first priority queue means this first priority queue contains all the values in which my sublist was 1, and this list contains the values. This list contains the indexes where the sublist was 1. This is for sublist 2. This is for sublist 3. Okay. Now as I get 1, 2 or 3 sublist, I add the value in my queue and the index in my list, or you can make it as a queue as well. Okay. Now I sort the indexes because it was a list. If it was a queue, it would have got automatically sorted, and then I just place it based on the indexes, which means suppose here my first priority queue will contain 5 and 8, and my first index list will contain 0 and 2. Now I will place the smallest of the queue with the smallest of the list, so 5 comes at 0 here. Now second smallest of the queue with second smallest of the list. So this is what is done. I am pulling elements from the queue and placing it at the least index of the list. Okay. Now an example of another question where you can use priority queue. Your friend is a gambling addict. He wants to play maximum number of games such that his balance never drops below 0. His starting balance is 0. In each game, you can either earn money or you can either lose money. Okay, you have to uh, find the maximum number of games he can play without having a negative balance anytime, which is not possible basically. Okay, so the idea for this is that suppose you have this entire array in your queue. Okay, now what's the sum of this? Minus 3, minus 5, minus 5, 1 and 6. So the sum becomes minus 6. Yes, the sum becomes minus 6. Now I want to play the maximum number of games. So if my net balance is coming minus 6, then what operation do I need to perform? I should not play the game where I have lost the most money, right? So I will remove minus 5. Okay, then my sum becomes minus 1. Then I can remove minus 5. Now my sum becomes 4. So by playing these three games, I can assure that my total balance is coming more than 0. But the issue is कि if I'm playing this game, then my balance will instantly go below 0 and I won't be able to play this. So how do we need to tackle this? We will check this condition at every end. Okay. Basically, at every game, you will add the current element into the queue, and while your total is less than 0, you will push out elements from the queue. Now what will this do is, at every step you will have a positive balance. which will assure that at the end as well, you will be left with a positive balance. Okay, moving on to another question. You are going to the gym for K days and there are N exercises which you learn along the day. You require 1 day to complete one exercise and you can perform one exercise only once after the 8th day. You have to calculate the maximum number of muscle gain you can achieve. Okay, now let's explain this with this case. Now on the second day, I learned 3 exercises. One with profit 1, next with profit 2 and third with profit 5. So which one should I take to have maximum profit? This 5 one. So I add 5 to my answer. And this remaining 1 and 1 stays in my queue. Now on the third day, I will learn about this one and this one. And these two get inserted in my queue. Now what is the maximum? 7. So I add 7 to my total. Now at the fourth day, I don't learn any new workout. But what I already learned before stays in my queue. So this 2 and this 3 is still in my queue. So I will choose this because this has the maximum profit. 5. Now at the fifth day, I will learn this workout. And hence my maximum will be 8. So I will add 8 to my answer. And at the sixth day, I don't learn any new exercise, but I have these two in my queue already. So I'll take the maximum, which is 1. So if you take the sum of all of these profits, you will receive your final answer. So basically here you need to learn that when do you need to append this value into your queue. Once it is appended into your queue, then you take the maximum among all of those elements which are present in your queue. Now the other similar question with a very small change. Over here, the only change is your time goes till 10 raised to 9. So you can't iterate from this from 1 to 10 raised to 9. So over here, it's like if your see first of all you need to sort all of these tasks by earliest arrival time and smallest execution time. Okay, this question is a basically you need to do that task first which has the earliest arrival time, and if there are many choices with you in your queue, then you will perform the task having minimum execution time. So this first value is arrival time, second value is execution time. So first you will execute this one 6 with a time of 4. Now after this you have reached time is equal to 10. So since you are at time is equal to 10, all of the remaining tasks will be inside your waiting queue. Now among those tasks, you have to choose the one having least execution time. Okay? It is not that 8 will be executed before 10. 8 and 10 both have already reached my queue. So now out of them, I will choose the one that has minimum execution time. Okay, so this takes a bit careful manipulation so you can handle time till 10 raised to 9. It's basically that since there are no times like 4, 5 or 9, so you won't iterate over them. You will iterate only over those times which are present over here, nothing else. Okay, so Thank you guys for watching this video. Make sure to subscribe and share this video to your mates, and click on the notification bell to never miss a video.